Good morning, friends. Let's wait for 2 more minutes so that others will join the session. After that, we will begin our session. Thank you. Good morning, all of you. Welcome to this course on Docker and Kubernetes. Before going to the actual discussion of Docker and Kubernetes, let's understand the philosophy of Plato. Plato, in his philosophy and in his book, The Republic, he said that necessity is the mother of invention. Okay, who said this? Plato had said this. What does it mean? Human being has invented various technologies like agriculture technology, the various industrial technologies like printing machine, the computer, and everything was invented. Why those things were invented? Because of their needs in those particular time. For example, agriculture was invented because there is growing number of population. In order to meet the food requirements of the population, definitely the food supply has to be increased. In order to achieve that, agriculture technology was invented. People started farming the land, okay, cultivating the land so that the people needs of food will be met. Like that, computer was invented because there is need for high computation. For that, initially computer was invented. So various application, all those things were invented because of their needs. Likewise, the concept of Docker and Kubernetes, especially the concept of Docker was invented because the software industry was facing some issues. What were those issues? How the containers, how the Docker has solved the issues? Let's understand that. Any software development life cycle will begin with what? SDLC, software development life cycle will begin with development of what? Development of source code. Okay, development of source code. Source code. Who will do this? Developers will do this job. Source code. Actually, my operating system is Ubuntu, so GNU Paint is not that much effective. So I am using some online paint tool. This is what? Development tool. Developers or development team, you can say. Once this source code has been developed, it will be stored into repositories or source code management tools. Let's say GitHub in our case, or in general, let's call it as SCM. What it is, let's call it as SCM, source code management tool. SCM, source code management tool. Let's say that GitHub in our case, and different project people, different organizations will have their own private repositories like Azure repos. Some people will be using Bitbucket. So all those things stuff will be there, right? So source code management tool, the source code will be saved into it. Later, this source code has to be built into an artifact. For example, if it is Java based application, Maven will be the build tool. Artifact will be generated. That is fine. Let's not worry about that. And that artifact will be deployed into servers. Okay. But here the problem will be, once this artifact has been deployed into dev environment, this is what? Dev environment. The application is successfully working. Let's assume that once this application has been deployed into the dev environment, the application is successfully working. But when the same application has been deployed into QA environment, the application failed to run. Why? Because, for example, in simplicity, if you take Java based application, the environment that is required for the Java is OpenJDK. Okay. And you know that, let's say this is Java environment. In this development machine, it may be a Kubernetes cluster, or we are studying the things before existence of this Kubernetes cluster, right? So before container, it will be deployed into some Linux machines. And the application will be deployed into some environment. Environment, I mean to say, it's not a dev, not QA. For the Java application, the required environment is OpenJDK. And in Java, there are various somebody, Sivaprasad, could you please go on mute? And there are different versions of Java, and there are different versions of operating system. Let's assume that in dev environment, the operating system used was Ubuntu 18. The operating system used in QA environment is Ubuntu 20. Okay. And if you have experience with these two versions, or if you have experience with the latest version of Ubuntu, that is 22, some application will be failed to run in Ubuntu 22. For example, if you already have the knowledge of Kubernetes, I don't expect that. If you use kubeadm tool to install Kubernetes in Ubuntu 22, you will face some problem. What I mean to say here is, the operating system from dev to QA may be same, but the versions will be different. That may be the reason for the application to be failed in QA environment, which was successfully running in dev environment. That is point number one. Because of operating system conflict, the application may be failed to run in QA environment. The same application was successfully running in dev environment. Okay, what can be the reason for the application to be failed in QA environment? Because of operating system version conflict. That means here they may be using one kind of operating system, here they may be using one more kind of operating system. Let's suppose that same operating system has been installed in dev and QA environment and the prod as well. But what about the Java version? Here Java 11 may be installed, here Java 8 may be installed. The application which may be successfully running in the dev environment with this version may be failed to run in QA environment because of different version of the Java. That can be another reason for the application failure in QA environment. And even if this Java version is also same, there are also multiple binaries and packages we have to install in particular machines for the application to run successfully. That binaries and that libraries may be having some version conflicts. They may be having some operating system compatibility. They may be facing some issues with the particular hardware kind of things also. So the whole point I'm trying to explain here is the application which is deployed into the dev environment, okay, can be deployed into the QA environment, the same application, but because of the environment issues, because of the dependencies, versions conflict, the application is successfully running in one environment, and if it is failing in another environment. Let's suppose that some way the DevOps team or some maintenance team has managed to install exactly same versions in dev and QA environment. They have achieved with some difficulties. Let's suppose that is successfully working in QA environment. What about prod environment? What about staging environment? There may be same conflicts will happening while the application is running. We are not sure because of some conflict the application may fail to run during the production stage. Okay, this was the problem. What was the earlier setup? So let me go into the earlier setup, the hardware and software. So for example, the organization will be having, let's suppose that they wanted to deploy some application into some machine. Here, definitely we have to install what? Operating system has to be installed. Let's say this is Windows operating system. I'm not able to write this. Windows operating system. This is host operating system. For suppose if this hardware is having sufficient resources to deploy the application and the application needs Linux environment, Linux operating system, how to achieve that? Before this concept of containers, that application will be deployed into Linux machine. We can set up that Linux in the same host machine. For that, we have what? The concept of hypervisor. Hypervisation we have. Let's suppose that hypervisor has been installed in this. Very, very important, hypervisor. Okay, for example, Hyper-V or VMware. Hyper-V. So what this hypervisor will enable us to do, it will enable the team to have the Linux operating system on top of this Windows operating system. Okay, this is very important. We can have multiple operating systems, okay, within the Windows host. How to do that? With the help of hypervisor, this was achieved. This technology was invented. So, for example, this developer one needs this Ubuntu operating system. So, Ubuntu operating system can be installed within the same hardware, and we can give this access to this developer one. What after application 1 was developed? App 1. App 1 in the sense here the source code. Definitely in order to develop this, the dependencies have to be installed, right? So that the application they will develop this. For example, let's say OpenJDK. So the developer will install the dependencies. After doing that, it will enable him to develop the source code. This will be pushed into the source code management tool like GitHub. Okay, like GitHub. Once this has been developed, it will be deployed into the dev environment or QA environment. Okay, whatever the may be the case. Here, the most important thing is here only the application source code will be pushed to the source code management and it will be deployed into the QA and prod environment. But if we use the concept of containers, how the setup will be? Here, one more thing is we need full-fledged Ubuntu operating system in the same hardware. Okay, so what will happen? In order to install this Windows operating system, some amount of CPU and memory will be consumed. Okay, and in order to install this hypervisor, some amount of CPU and memory will be consumed. Okay, what we are installing all those things just to develop this application and deploy this. Okay, and in order to install this Ubuntu operating system, few more amount of CPU and memory is required. Okay, for installation purpose only this much of CPU and memory has been utilized. Okay, so we are not optimizing the resource utilization. You will understand this concept only if you go to the concept of containers. What will happen in the form of container is, let's suppose that this application has been deployed into this only and the application 2 has been deployed into this particular virtual machine 2. This is say Ubuntu. This is also Ubuntu. This is also Ubuntu. Okay. What will happen? In order to run this machine also, a full-fledged operating system is also required. Okay. This is the problem. What is happening? Only source code has been pushed to one environment to the other, but the dependencies are newly installed in the dev and the QA and prod environment. Okay, these dependencies are not transferred. Only source code has been transferred. Imagine if you have a mechanism to compact this source code along with the dependencies. Okay, so that there is no concept of version conflict. This application along with the dependencies will be deployed into the dev and QA environment. Okay, if this application is successfully running in the developer machine, definitely it should be running in QA and prod environment as well, because what we are doing here, we are just transferring application along with the dependencies. That means application along with the OpenJDK and other binaries are also being transferred from this environment to this environment and from here to here, and the same has been deployed. That is what the concept of containers will enable us to do. Okay, how it will be solving? The concept of containers will enable us to shape application along with the dependencies from one environment to the other environment. That means the developer will be able to push this application source code along with the dependencies to some central repository where the Docker images will be stored, and that thing will be deployed into this. I know you won't be understanding what the Docker image is as of now if you don't have any prerequisites, if you don't have any knowledge about the Docker. And one more thing I want to emphasize here is there is no prerequisite for this Docker and Kubernetes course. For Kubernetes, Docker is a prerequisite. For Docker, there is no need of any prerequisite course. If you have some basic Linux knowledge, that will suffice. Otherwise, also no problem. Okay. So here the thing is, with the concept of containers, we will be able to ship the application along with the dependencies from one environment to another environment, so that the version conflict, the environment conflict has been resolved. Now, I want to take you to the analogy of the shipping industry, okay, for a few more minutes, so that you will be having clear idea. You should have a clarity about this, what the Docker containers will achieve, what was there before. Okay, before hypervisor was there, now we will be having what? Docker container runtime. Okay, before that, let me go to the shipping industry. This concept of container was taken from the shipping industry. Let's suppose that a person is owning a ship of capacity 100 tons. Okay, 100 tons. A customer comes to the ship owner and says that he wants to transport 30 tons of fish and 20 tons of raw material from one location of the world to the other. For example, from China to Sri Lanka. Okay, he wants to transport his fish and the raw material. Before the concept of shipping container, how it was achieved? The fish will be put here. Where are the ships? Let's assume that these are the fish. The fish will be, the 30 tons of fish will be placed in this ship body, and 20 tons of raw material will be placed, or something like this. Okay, let's say this is raw material. During transportation, what will happen? There is a possibility of mixing up this fish and raw material. If that happens, fish and raw material both will get spoiled. Why? Fish requires cold storage. Fish will be put into ice cubes. What will be put into ice, whereas the raw material requires dry environment. If there is no separation, if there is no compartmentalization between these two materials, what will happen? During transportation, what will happen? These two things will get mixed up and the two materials will be spoiled. In order to eliminate this, the shipping industry came up with the concept of container. What does it mean, container? What does it mean by container? Containers are nothing but empty boxes. Containers are nothing but empty boxes. If you see, these are the containers. In everywhere you will see the containers. Even the road transportation also, things will be, the goods will be carried through the containers only. In railways, containers will be used. In airways, containers will be used. In shipping industry, containers will be used. These are the containers. Containers are nothing but what? Empty boxes. Now, what is its relevance is there? Now, the shipping industry came up with the concept of containers. Instead of putting the materials together like this, they have created empty boxes. They have created empty boxes called containers. And these empty boxes will be in general of equal volume. Let's say this empty box, this container will be of 10 ton. This will also be of 10 ton. This will also be 10 ton. Total, the capacity is 100 tons. This ship can carry 10 such containers, right? So now These 30 tons of fish can be put into 3 different containers, and they can make these containers as cold storage. That means they can fill this container with what ice, and they can put the fish inside there. Like this, for this container also, they will arrange some cold storage, and 10 tons of fish will be put into this container, and 10 tons of fish will be put into this container. And there are 7 more empty boxes called containers. So 2 will be used for this raw material, and this raw materials requires dry atmosphere. So this raw material will be put into that kind of dry atmosphere. Now, what will happen? They will put this into, I don't know how to drag this into here. This is not serving that purpose. These these things will be put inside this particular ship. Okay, these things will be put into the ship. Even after long duration of transport, there is no concept of mixing here. There is no problem of mixing here, because in these 3 boxes, fish is there separately, and in these 2 boxes, raw material is there. So here, there is no problem of mixing. This is how the shipping industry overcome the earlier issue. Then how it is analogous to software industry? Let's say that these 3 are Java application and these 2 are Python application. Java application requires a separate kind of environment than that of the Python application. So each container will be of Java based container, and these things will be mixed, don't be mixed with the other containers. Okay, so it will be having environment, I mean to say operating system along with the dependencies. Here also it will be having its own operating system along with its own required dependencies. This Python will be having Python environment, and at the same time they are isolated in some aspect. Okay, in this operating system and environment aspect, they are isolated, but in some aspect they are utilizing the same system resources. They are mutually sharing the system CPU and memory and disk. Okay, so the aspects in which they should be isolated, they were isolated with the concept of containers. At the same time, they are utilizing the common resources of this system. Okay, so you can think of containers in software industry as empty boxes. These empty boxes as a container. So that the Java application you can think of as fish, Python application you can think of as raw material. So they have their own environment. Okay, so earlier, now what you can say, you can have one Java application in this container, you can have another Java with another version of Java in this container. Okay, this is how the concept of shipping, the concept of container has solved the problem. So now what we are doing, we are compacting, we are packaging the application source code along with its dependencies in the form of containers. This is application 1. If you take application 2, here the application 2 along with its dependencies are also packed. Okay, so those will be forming as containers. Now let's go to the CI/CD. In DevOps, what is the relevance of this Docker and Kubernetes? Okay, you will understand the difference after a few minutes. Now first the developers will be writing the source code, and they will push the source code to source code management tool. Let's suppose that quickly. Let me draw this as GitHub. Okay, this is a developer machine, dev team. Okay, they have pushed the application source code to the GitHub. Okay, later it has to be built into artifact. Who will be serving that? We will be having Jenkins integration tool, CI/CD tool we will be having. Let's suppose that this is our Jenkins. Okay, this source code will be pulled by the Jenkins. Okay, and Jenkins will be integrated. Maven will be installed in the Jenkins so that an artifact will be generated from the source code, and this artifact will be pushed to where? Artifactory like Nexus, from Nexus. Okay, and this artifact is nothing but jar and var file. This artifact finally has to be deployed into the Kubernetes cluster. Okay, KTS. So before doing that, what we should do? Let's say this is Kubernetes cluster. KTS. I will tell you what it is. Then it will be from Nexus. It will be pulling again from Nexus. It will be pulled into the Jenkins, and Jenkins we will install what? Docker. Docker will be integrated with the Jenkins. The job of this Docker is to containerize the Java based application or whatever the application. In our case, it's a Java application. Docker is nothing but containerization tool. Containerization means the concept of creating containers is called as what? Containerization. The process of making containers. What is container? Container is nothing but an empty box we can think of at this level. At this level of understanding, Docker will create containers for this Java application. And this container will have application along with its own environment. For example, it's a Java application, it will be having OpenJDK and other things, other required dependencies. This container, this Docker will create Docker images. Docker will create what? Docker create Docker images, and these images will be pushed into some central server called registries. The source code will be stored into source code management tool, and the Docker images will be stored into registry. Okay, container registry. Okay, so in this registry, Docker image will be stored. Then what is Docker image? Docker image is nothing but this application source code along with its dependency. What it is? Now let me tell you what is Docker. Docker is a containerization tool. Why it will be used? What is the need for containerization? Because different applications will require different environment. So this Docker will enable us to tag the application along with its dependency. If there are n number of applications, then n number of containers will be created. N containers will be having n applications along with its own dependency, so that one application will be isolated from another thing. You will understand this when we go into the practicals. Okay, Docker is containerization tool. What is containerization? The process of making containers is called as containerization. What is container? Container we can think of application along with its dependencies. Okay, application along with its dependencies is called as what? Is called as image, container image. Okay, there is no problem. I can tell that it can be a container at this level of understanding. Then what is container? When we execute this image is nothing but what? Application one, that is application source code along with its dependencies called as what? Container image or Docker image. When we run this image, we get container. We'll understand this difference. Okay, when we run this thing, we will get what? We will get the container. This is nothing but what? runnable instance of image, Docker image. Don't worry, guys. If you don't understand, also no problem here. Okay. So now, how this can be achieved? How this can be achieved? First, Docker is nothing but containerization tool. What is containerization? The process of creating or making containers is called as what? Containerization. And as part of containerization, we will get the Docker images. When we run that image, simply it will become containers. Okay. If you have confusion, don't worry. This confusion will be eliminated once we go into the practical things. Now, here Docker is a tool to containerize the application or to Dockerize the application, right? That is one point. Where we install this Docker, earlier we have a setup. What was that setup? We have a host machine, we have Windows operating system, and if you want to have Linux operating system, we should install hypervisor, and we can have multiple operating system like this. But in this case, what we are doing is we have to install full-fledged operating system in order to have the Linux environment. But if you come to Docker, we will be having infrastructure. That means what? Hardware of particular configuration like CPU and memory. And there is no doubt that we have to install operating system kernel. It can be Ubuntu operating system or Windows operating system or Mac OS. And in place of hypervisor, we will install Docker. What this Docker will do? Docker will containerize the application. Okay, Docker will containerize the application. As a part of this, the result will be containers. This is one container, this is another container, this is third container. Now, earlier also, we have one virtual machine, we have another virtual machine, we have three virtual machines. Then what is the advantage here? Here, instead of hypervisor, we have installed some or the other tool, and we are calling it as the Docker. And in order to have three virtual machines, here also we are creating three containers. Okay, then what is the advantage? If you see the difference carefully, here we have installed full-fledged operating system. But in case of containers, we don't have full-fledged operating system. These containers will be using underlying operating system kernel. Okay, these containers will be using underlying operating system kernel. In our case, let's say it's a Ubuntu operating system. It will be using the Ubuntu kernel. Now, the most important thing here we have to understand. I said that this host operating system can be Windows. Okay, and we can install Docker in Windows machine as well. Okay, most important point is we will have only Linux containers. We will have only Linux based containers only. Here we have Linux virtual machines. Like that, we have virtual machines in the form of containers. Here you can have Windows virtual machine as well, but in the case of containers, we will be having only Linux based containers only. So this Linux based containers should have only Linux kernel. But what if it is Windows operating system, and if we install Docker in that Windows operating system? We have to install Windows subsystem for Linux in this operating system along with the Docker. Okay, that is one of the important point. What I'm telling, if it is, so now what we are doing, we have hardware. In hardware, we have, this is hardware, let's say some amount of CPU and memory. Now we will install Windows operating system. And I said containers will be using only Linux operating system. Okay, if it is Windows operating system, if we install Docker, then let's say this is Docker container runtime in general. This is Windows operating system. This is hardware, CPU and memory. Okay, so if you want to install Docker in Windows operating system and if you want to create containers, you have to install Windows subsystem for Linux. Windows subsystem for Linux. This is nothing but the Linux kernel, and you can have 100 containers also. These 100 containers will use this same kernel. Okay, but if you take hypervisor concept, for every virtual machine you have to install full-fledged operating system. In the case of containers, we have eliminated the need for installing full-fledged operating system. Okay, that is one thing. And here, so this application along with the libraries, it is called as what? Containers or the Docker image. This can be transported. Okay, this can be transported. These two things can be packed. That is what is container. But here in the case of hypervisor, no, we cannot ship these libraries and the operating system. We can ship only the application source code. We can't ship this environment. Okay, so in the case of container, with this concept of packaging of the application along with these libraries, we have eliminated the version conflict. So the same application and the same environment can be deployed into the QA environment and prod environment. Okay, this is the introduction to the container. Okay, now let's understand the Docker and the difference between the Docker and Kubernetes. After that, we will, as a part of this workshop, we will do some demo, and after that, we will proceed. Okay, so I have created about 65 pages of Docker material. You can directly use this material in your production or in your real time. You can use this with this Docker document. You can completely achieve the Dockerization of various applications. Okay, we will see various Docker files. We will see Docker files is very, very important both for developers and DevOps engineers. Okay, Docker is very much important for developers as well. Okay, we will write the Docker files. We will see Dockerization of various applications like Python, Java, Node.js application, Spring Boot application. We will see practically very, very simple Docker and Kubernetes if you learn properly and if you use these notes. For Kubernetes also, I have made notes. So I think I got some questions in chat box. Okay, I will. Okay, no questions. Are you sharing this document also? Sure, I will share my entire document. Okay, entire Docker and Kubernetes document as well. Kubernetes, I have about 90 pages of document. I will still have to refine it something. Okay, I will do this. With this Kubernetes material, in this Kubernetes material, you can do every Kubernetes project. That is for sure. In my real time, I will be using my own document. Okay, so we will see this Kubernetes in both Azure and AWS, and we can also install on-prem Kubernetes cluster. We will do with our own hands, and with this course, you can also grab certified Kubernetes administrator certification as well. Okay, after this course, if you practice for a few days, if you do some practicals, then you will be able to crack the certified Kubernetes administrator certificate as well. Okay, so this is my Kubernetes documentation and this is my Docker documentation. And now let me introduce to the concept of Docker. Okay, Docker is nothing but containerization tool. Docker containerization tool Containerization means the concept of or creating containers. Creating containers is called containerization. What is container? Runnable instance of Docker image is called container. Then, okay, you confused. I know that. Then what is Docker image? Image is nothing but application source code along with its dependencies. What does it mean? For example, it's a Java-based application. Java source code, the application source code, along with the OpenJDK environment. That are the dependencies. If there are any other dependencies, that dependencies. Okay. If you pack application along with its dependencies, then it is called as what? Image. More particularly, in our case, it's a Docker image. Once we execute this image, once we apply run command, then it will become container. Okay. Then what is Kubernetes? Kubernetes is nothing but container orchestration tool. Container orchestration tool. Orchestration means what? The process of managing the containers. We have created containers using Docker. How we will manage the containers? Managing the container means if the traffic is being increased, instead of one container for the application one, we can replicate, we can scale up the containers very beautifully. That job of scaling up the containers, networking of the containers, the scaling down of the containers, and healing of the containers when some containers are terminated. This thing is called as was management. To management, to manage this activity of the containers, to manage the containers itself, we have the tool called Kubernetes. Okay. So now what is Docker? Docker is a containerization tool. Kubernetes is container orchestration tool. Orchestration means just management of the containers. We will see this practically. Now let's go to the practical. Where do we install Docker? We will install Docker. You can install in Windows machine and you can install in Ubuntu machine or any other Linux machine as well. If you want to install Docker in Windows machine, along with Docker, we have to install Windows subsystem for Linux. Why? Because Docker containers are Linux-based containers. As of now, there is no Windows-based container. So definitely this container needs Linux operating system. So in Windows host, we will install Windows subsystem for Linux along with the Docker. But if you are installing Docker in Linux machines, there is no need for Windows subsystem for Linux. Okay. And one important point I want to make here is whatever the task that is not able to be achieved by the Linux operating system, that can also be not achieved by Docker. What does it mean? For example, if some application is there, this application is not fit for Linux operating system. Okay, Linux operating system means a Linux, this Linux machine. If this application is not fit for Linux, it is also not fit for containers. Why? Containers will use the underlying operating system only. So if this application is not being able to run by this full-fledged or Linux operating system, this task also can't be done by the containers. Okay, so those tasks which can be done by the Linux operating system, those tasks only will be done by the container. If your Linux operating system is not able to run particular application, that can't be achieved with the containers. Okay, that is. Now, the machine in which we install Docker is called what? Docker host. Docker host. Machine in which Docker is installed. Docker is installed. In our case, My operating system is Ubuntu, that's fine. But in general, what we will do, if your organization is using cloud, we will create AWS EC2 instance and we will connect to this AWS EC2 instance. In our case, it's a Ubuntu 18 version or 20 version. I'm not sure about that. So this is just a Linux machine. When we install Docker in this, then this machine is called as Docker host because it is hosting Docker. Okay, so the machine in which we install Docker is called Docker host. Then another term we have to understand very clearly, Docker image. Docker image we have already said, captures dependencies. Container is when we run this image, then it is called container. We will store all these images in a central server called as what? Container registry. Generally, where we store our application source code, we save our application source code in repos, in repositories, for example, GitHub. Likewise, we will save our images in container registry. Okay, so by default, this hub.docker.com. Hub.docker.com. So this is somebody asking some question. Yeah, thank you. Thank you. Okay, this is hub.docker.com. This is where we store our Docker images. What is Docker image? Nothing but application along with its dependencies is called as what? Docker image. That is what I have written here. So all these images will be stored in some central servers. That is hub.docker.com. It's a public registry. We will also see Azure repos, Azure Container Registry, that is ACR, Elastic Container Registry, that is Amazon Web Services, AWS Container Registry. Okay. Now, how to install Docker? Just as simple as go to our documentation. Okay, just connect to that Linux machine. How do we connect to this machine? If we have AWS knowledge, that is fine. Otherwise, in classes, we will see how to launch EC2 instances. This is my EC2 instance. So because my operating system is Windows, I can directly connect to this using SSH protocol. So let me open my terminal. Okay, in classes, we will see in detail how to connect to the Linux machine also, because some people may not be having that idea. So I have to copy that SSH command. Okay, this is my local Ubuntu terminal. So now I'm SSH into permission denied. No, but yeah, I have to go to my public keys located here. So I have to go to that. Okay, so I connected to the Ubuntu machine. This is EC2 instance which is there in this. So how to install Docker? Just use our documentation. You don't need to search anywhere. Just log in as sudo user, run this command. It will download the shell script required for the Docker, then execute the shell script. And if you execute that command, see, Docker has been installed. Okay, Docker. So this is the Docker command line. Then I have one more thing to say. How we will interact with the Docker through command line only. For Windows, we have user interface also, but Windows we won't be using in the real time, right? We will be using only in the Linux machines. Now, when we install Docker using these two steps, along with the Docker CLI will also be installed. Okay, that is called what? Docker command line interface. Every command, if you want to execute in Docker, you will use Docker. Okay, Docker image ls. Image ls. I want to see the list of images. Okay, so for that, Docker image ls. There are no images. What are images? Image is nothing but application along with the source code, application along with the dependencies. Okay, in my EC2 machine, there are no images. Okay, how to download the images? For that, we will be having, so this is the architecture. We have the Docker host. Docker host is nothing but the machine in which Docker is installed. In our case, the EC2 instance in which our Docker is installed is called as what? Docker host. How do we interact with the Docker host? Through client. What is client? Docker CLI is the client. How do we install this? You no need to separately install this. Once we install the Docker, along with the Docker CLI will also be installed here. So then what is registry? Registry is nothing but the server where Docker images are stored. Okay, so Nginx application, Nginx image, Ubuntu image, we will see in detail in practical. So this image has to be downloaded from the registry to our machine. How do we do that? Using Docker pull command. Docker build command we will use. We will understand this during the course. We will use the Docker run also. Okay. So for example, I want to deploy Nginx application, default Nginx application. In Linux, you know how to do that. But in case of containers, how do we do that? In case of containers, we have to download the Docker image for Nginx hub.docker.com. Search for Nginx. The Docker community has already built some Docker images and it has stored in hub.docker.com for general public. Okay, you no need to pay for it. So Nginx is a Docker image. What is Docker image? Again, application along with the dependency. So now Docker pull Nginx. We have all the commands in our notes as well, sequentially. So let me connect to the Docker host. We are also already into Docker host. Paste it. What I'm doing, I'm downloading the Docker image from the hub.docker.com. When we go to real time, we will also see how to connect with the AWS container registries and Azure container registry. Okay. As of now, if you don't mention any servers, by default, it will be pulling images from hub.docker.com. So download the image, Docker pull Nginx. See, you will see all these things in our course. What does it mean by this? Okay. Those are called Docker layers. Docker image ls. See, that Nginx has been downloaded into that repository has been downloaded into us, and the version is latest. The ID Docker image is this one. Okay, now we have Docker image. Let's see Docker container ls. Do we have any containers? No. What is container? If we run that Nginx image that we have downloaded just now, then that will be becoming container. Container is nothing but a runnable instance of the Docker image. Now, how to run this image? Just simply Docker run this image Nginx. Okay, if you do this, see that Nginx application is successfully running. How to check that? For that, we have to use the public IP along with the Nginx port. Put 8080. Okay. Okay, we have to map the port mapping, right? So I forgot to do that. You will understand port mapping later, but okay, how to do that? So before going to that, let me use this command. I will explain this just for a demo purpose only. This is not a full-fledged class, right? So now let me exit from this using Control C. Now let's see Docker container ls. See, container has been stopped. Container Docker ps-a. If you use this, it will show stopped as well as running container. So let's not worry about that. We'll see this during the course. Now what I'm doing, I'm creating a container called app server. I'm naming that container as app server, from where I want to create this container from running a Docker image called Nginx. Where is this Nginx is there? It is downloaded into our local machine already. Okay, even if you don't download this also, by default, this command will download from hub.docker.com. We will see that. So I want to run a container called app server from a Docker image called Nginx, and let's do port mapping. Okay, so let's do port mapping. How do we do that? So port mapping. So we are doing this. Else also can do and see what is the Nginx port. 8080 or 80, right? Okay. So -p. Let's map with. Sorry, I have done some mistake. Or else let me type that Docker run name my app. Okay, so I want to perform port mapping. You will understand this from this image. Okay, so now how to execute this? It will take some time to reflect the application to be run successfully. Okay, Nginx which port will be using. Or else let's start Tomcat server. Okay, not wasting any time. I forgot the port number 80 or 18, so no problem. So we have the Docker image. We have, so the status of this is exited. So now let's remove those two images or those two containers. The container ID. Copy here, port here. So let me copy this, paste it here. Docker ps-a. So we have no. So now let's start the Tomcat server and perform port mapping. You will understand this later. For Tomcat, the Docker image is Tommy. Okay. So the environment that is required for Tomcat application will be packed together with its source code, and that is called as what Docker image, and those images are stored in Docker hub.docker.com, and we are using that image. Now if we use this, what is happening? We did not download the Tomcat earlier, so this run command will also pull the Tommy image from the hub.docker.com. Why it is Tommy? How do we know that we have to write the Tommy? We will understand this in the process. Okay, So this application will be running now. Okay, the port we have used is 8080. Public IP only have copied, right? So okay, 700. This is the Docker host port. Sorry. This is the Docker host port. This is the container port. What does it mean? You will understand that. Okay. So we are successfully able to run this Tomcat. Likewise, let's also try. So let me interrupt this process as of now. We can push this to the background also with -D. But so let's not do this. Docker run. Let's use Nginx application and let's use I think for Nginx let's use automatic port mapping. But I want to push the logs to background. So whole point of explaining this is I want to show the container. So now Nginx is now a container. How to achieve this Nginx without containers? You must be knowing that process. Otherwise, also no problem. Okay. Earlier, this Nginx will be directly installing in this Linux machine, but we are running a containerized Nginx. Okay, and we can run multiple Nginx machines using different containers, right? So this is my app one Nginx container. So now let's see Docker PS. Okay, so the port is 49154. 49154. Automatic port mapping has been done. 49154. So your Nginx application is successfully running. You can create one more container also. Okay, let's say my app 2. This is another container. See, total we have 2 containers from same image. We'll understand this thoroughly during the process. Okay, so from the same image, we can run multiple containers. You can run 100 containers. We have to download the image only once, and from that image, we can run as many containers as we want, and we can customize them. Okay, we will learn during the Docker file and the Docker commit command how to customize, how to create our own Docker images, how to run our own containers, how to Dockerize our own applications, how to save them into the public repositories, how to save them into our own organization repositories. We will understand that. Okay, so this is now how many containers are running now? Docker ps-a. Okay, 2 containers. You can run as many containers you want. Here the point is, even if you run the 20 containers, those 20 containers will be using underlying operating system only. See, but in case of hypervisor, if you want to run 100 application, for example, if you want to run 20 application, you have to run 20 virtual machines. Okay, for example, if you want to get the isolation. Okay, so for those 20 virtual machines, we have to install 20 full-fledged Ubuntu operating system. Imagine, just for running the application, we have to install full-fledged operating system. But in case of Docker, we have eliminated the need for installing full-fledged operating system. That is very, very important point. Okay, if you see this diagram also, see here guest operating systems are there. Here we don't have these virtual machines or these containers will be using the underlying operating system. Okay, that is how it will work. Then now let's understand. Jenkins. Let's run Jenkins in containers. How to do that? Generally, how do we install Jenkins? If you go to Jenkins documentation, installing Jenkins in Ubuntu. What we have to do? Let's take IBM. You have to perform all the steps. Okay. So for that, in order to Jenkins, what you need? Jenkins is a Java-based application, so definitely Java should be there. Okay. So without Java, you won't be able to run the Jenkins. Okay. You have to perform all these steps. Even after performing all these steps, there is no guarantee that we will be able to successfully run the Jenkins. Okay. And before doing this, you have to install Java. Which version of Java you have to install? You should know that. If you use the other versions of the Java, which is not fit for the Jenkins, waste of time, waste of resources. Okay. So let me run Jenkins in a container, see how it simplified our work. Okay. So for that, for Jenkins, I know that because I have worked a lot about Jenkins. So for Jenkins, I know that Jenkins/Jenkins is the official Docker image. We will understand this. What is official Docker image? So Docker image ls. We can pull the Jenkins before, or the run command directly will pull the image from the hub.docker.com. So now let me see if we have any running containers. We have already running containers. Let me remove all these containers. I want to remove and stop all the I want to stop and remove all the containers. How to do that? Docker ps aq. This command we will be frequently using this in our real time. So now if you see, we don't have either running and stopped containers. Now let's run Jenkins in a container. See, before the container, you have to install Java, you have to run all these steps, and you have to configure Jenkins. But using these containers, let's see. 70704. You will understand each and every letter and every word in the class. See, unable to find the image locally in our EC2 instance. So Docker is trying to download the image from hub.docker.com. Okay, pulling means downloading. And so I want to run this Jenkins container in a detached mode so that the console logs won't be shown here. If you want to see the logs also you can see, but let's not do that. We have forwarded to 70704. Let's copy the public IP address of this particular machine. Okay, and use 70704. See, this is your Jenkins. Very simple, right? Using Docker, within one click, with only one command, we are able to successfully run the Jenkins. We will also deploy the Jenkins in Kubernetes. See? Application already started. Okay, you have to log into Jenkins. Where do we have to go? We have to go to this path. Which path it is? It is the container path. Jenkins is now running in what? Running in containers. So how to go inside the container? For that, let's see containers. So see, our Jenkins container is running. This is the container array. I have to go to this path and copy the password. How to do that? Okay, you can't go to this in our Linux machine. Okay, so if you do that, it won't be found. No such file or directory. Where it will be there? It is there in the container. The directory structure will also be there in the container. Will be there in the container for Jenkins. So Docker PS, how to go inside the container terminal? Container is nothing but what? A small virtual machine only you can think of. A lightweight virtual machine. So how to go into that virtual machine? Now I am into EC2 instance. How to go into the container terminal? Docker exec IT. I want to execute commands in container in interactive mode. Okay, using Boston. See, where are we? The prompt has been changed from our host machine to container machine. Now let's go to this path, cd bash. See, where are we? We are into the container terminal, container with this ID. Now cd Jenkins home, cd Jenkins home. I'm into that. Now we have to open this file. Initial password file will be there somewhere. Okay, go to secrets. Go to secrets. Here, initial admin password. Cat it. Cat command will be used for what? To view the content. So this is the password. Copy this content. Paste it here. Continue. See, we are successfully logged into Jenkins, right? Install suggested plugin if you want, if you know the Jenkins. See, now we are into the container terminal. See, where are we? We are into the container terminal. How to exit from this? Control PQ you can use. So the prompt has been changed from container terminal to the our host terminal, right? So this is the beauty of containers. By default, you will find the Docker images for many applications, but according to our application needs, we can use the Docker images and we can customize those things. Till now, if anybody is having any doubts, you can ask me, guys. I will pass for some time. In chat box, they have pinged. Somebody is asking again, will this document will be shared with you? Yes, definitely. I will share this document. Whole document will be shared with you guys. Okay.
Can I speak, sir?
Yes, you can speak happily.
Yeah. My doubt is, sir, you are taking these classes for only one day, or it will how this will go?
Yeah, you mean to say that you can attend for 3 to 4 days of demo also. The classes will be from Monday to Saturday. The timings are 7 a.m. to 8 a.m. 7 a.m. to 8 a.m. And
Okay.
for Monday, Tuesday, and Wednesday, you can attend free classes.
And any evening batch and weekend batch is there?
No, dear. As of now, there is no evening batch for
Any
me. Okay.
weekend only?
Yeah,
That
weekend also not possible for me because of some constraints. And one more thing is that they will be providing you the recording video. You can successfully use that. You can use that happily. Okay, because I will tell everything in clear.
okay.
Okay, so others will be asking doubts. Maximum, nobody will get the doubts. I will tell like that. Okay, so I will keep sessions in my view, and I will tell each and everything in detail. Okay,
And
so if anybody get,
how much duration it requires to complete? Actually,
it will take
sir, actually,
45 days.
I am a backend developer, and I'm fresh, means not much experience. So
Okay.
Dockers and Kubernetes I heard many times. So I thought I will go through that one, and as well as Linux is also for new for me. So Linux also you will be giving teaching.
No, I don't teach the Linux in this
Uh,
because this Docker and Kubernetes itself will take 40 to 45 days for me. Okay,
oh,
because I will tell thoroughly at the product at the real time level. I will tell you, and each and every command from beginning to ending, everything will be real time. I will be telling. Okay, and one more thing is that you don't require the Linux knowledge, but it is better to have 2 or 3 commands we will be using most frequently. I will tell you. Okay. So what I mean to say is there is no requisite for you to learn Linux before this. Okay. You will be able to manage it.
okay.
Is that
And
fine?
can I have your number, sir? I have doubts, some more doubts, so I can.
I
I,
think according to this conduct rules, I can't share my personal number, but you can contact the admins, or also if you pay the fees, they will be creating some group, Telegram or WhatsApp group. And before that also, before joining, you can call the admins and they will clarify your doubts. Okay.
okay.
Okay. And course fee will be 4,000. Very, very affordable. For 45 days,
And
the course will,
and
yeah.
so in DevOps, means other things also coming up, or these two only main things are it?
No. These two are heart of the DevOps, but these are very much used. But you have to learn other tools also for DevOps. You have to learn at least a cloud, AWS or Azure or GCP. AWS is mostly demanding, and Azure also very much growing. And apart from that, for DevOps, if you want to move to DevOps, you have to learn Jenkins. You have to learn configuration management tools. Let me list out them here for you. Okay, so before that, I want to create a Kubernetes cluster. So quickly, let me create that so that I will tell a demo to you in Kubernetes also. After I have done that, I will speak to you. Can stay online. So creating Kubernetes cluster in AWS or in Azure, very easy. Okay, and I want to name that as demo cluster, right? So role I want to use is this one. And anyway, so I have to configure this and everything. I will tell you what Kubernetes cluster is. So with these few clicks, you will be able to successfully create the Kubernetes master plane, control plane. Okay. So AWS as EKS as the Kubernetes tool. That means what? We have a platform in AWS that is called Elastic Kubernetes Service. With this, we can bootstrap our Kubernetes cluster in 15 minutes. With few clicks, see what will happen. The cluster will take about 10 to 15 minutes for creating. After that, we will add the nodes as well. So I know that you don't have, most of the people who have joined this, you don't have an idea of Kubernetes. Kubernetes will be having master and worker nodes. This master will be provided by the AWS. In which service? Elastic Kubernetes service of AWS. If you go to the container section of this AWS, go to services, go to containers. In containers, Elastic Kubernetes service is there. Elastic Container Registry is also there. These are for storing Docker images. So within few clicks, we will be able to understand this. I will also teach you how to create Kubernetes cluster using EKS, JKS, and kubeadmin, right? Now, it will take a few more minutes. So meanwhile, so let me clarify your doubts. Yeah, you can proceed with your doubt, Mr. Yeah, anyone is having any other doubts?
Hi, sir. Good morning.
Good morning.
So I
Yeah.
have some doubts. I think 1 or 2 days back, I just joined the 5 p.m. class because I was working in the office. Of during the office hours, in between I joined. So I somewhat knew that there is one class of this Docker and Kubernetes. So I have joined this class. So is this class and the class at 5 p.m. those are completely interrelated? I mean, I'm a bit confused about the course because that was the second session I joined. It was, you can say, kind of in between. So I'm not able to link up the things, how this is related to that, and will these concepts be utilized there? And if these both go simultaneously, then how the things will be managed, like some concepts we are covered or not in that discontinued.
Yeah, I don't know who is that faculty taking classes at 5 p.m. or 5:30 p.m. I don't know. So, and one more thing is that if you like that, you can continue with us. If times are not permitting for you to attend at that time, you can request admin to switch you from that batch to this batch. This is a morning batch, right? 7 to 8 a.m. So if there is time constraint, then that is fine. You can switch, you can request them. But regarding the content and all those things, I can't comment on that. But everywhere I don't know that faculty name. And can you please name that faculty name?
It was Shiva, sir.
I don't know about him, and but I don't. Please look at the course content, okay, and see. Okay.
So the contact number of admin, if I can get it, like is it the?
Yeah. Okay. I will share that with you now itself. Wait a moment. In short, I will be sharing with you guys. Let me get my mobile phone first. Double 77027. I'm typing it in the chat box. 03786. 77027038786. This is their number. His name is Nasir. Okay, you can talk to him. Okay.
This is
now
admin number, sir.
Yes, admin number. I think I used to contact with this guy only. He can tell you, he can clarify it out. Okay.
And sir, for this Kubernetes and in this one, so Linux Ubuntu locally should be there, no, sir? In my system also.
No, not needed. Because if you use the cloud-based machines, Linux machine, you should have some SSH client, whether it can be PuTTY or MobiXterm. I recommend MobiXterm. Okay, so I have MobiXterm also my Windows machine, but I logged into my Ubuntu. So this is my Ubuntu laptop. So you can, because you can directly use the SSH in your Ubuntu, right? If you have Windows, you can install MobiXterm or you can install PuTTY also. With that, you will be able to connect to the cloud-based machine. But if you want to install Docker in our own machine also, you can use that. You can use our own documentation. If it's a Linux, you can directly install that using that command. If you want to use install the Docker in your Windows machine, very simple. Install Docker in Windows. To search for this in official documentation, it will give you the steps. Docker desktop for Windows. Okay, exe file will be downloaded, and the requirements for this is, as I said, we have to install Windows subsystem for Linux as well. Okay, so you can download this very easily. Okay, if you go to this, you can install. Okay, so with these two, you will be able to run the Docker in your machine. But Kubernetes, you are telling that you will be using Minikube is there for having your own one node Kubernetes cluster in your machine. But I don't recommend that, but you can use it. But I will go with the real time only. We will be using real time. In real time, we will be using EKS or AKS cluster. So I will be using EKS cluster for our demo in our classes. But if you want to use Minikube, so you can use the Minikube also. Minikube installation we will be having in our own document as well. Very, very simple. You can install Minikube. It's a single node Kubernetes cluster that we can use for practice. Okay, but I recommend you to use the real-time things only, right? So EKS we will be using mostly if it is the AWS cloud. If the project is running in our, if you are using AWS cloud, then we have Elastic Kubernetes Managed Service, right? So cluster creation is very, very simple. Yeah.
You told through PuTTY if I will connect, so where I will get this Linux environment?
PuTTY and MobiXterm, right? Okay, in classes I will tell you. Okay, in classes, I will tell you, or else also MobiXterm I will be able to MobiXterm install for Windows. Just for you, Okay, copy link address. I'm putting that into the chat box. Admin name is Nasir. Okay, somebody is asking admin name. So I think it went for only one guy. So this is a mobile system, but you should know some steps how to use it. Installation is very simple. After downloading that file, you have to get executed so that it will be opening, and after that you should know some steps to connect to it. In classes I will teach you. Okay, as of now I'm waiting for the cluster to be created. Once it is ready, we can have 2 or 3 nodes in this, and so that we will be. So what is Kubernetes? Kubernetes is a container orchestration platform. That means using Docker, we will create containers. Those containers will be managed by the Kubernetes. Management means what? Whenever the traffic is being increased, for example, if you take Flipkart.com, and if the Flipkart is operating only in India, during night, there is no traffic. Okay, no or less traffic. In that case, the number of containers should be minimal. But during peak hour, what should we have? In order to handle more nodes, we will be creating multiple containers. So how to create the multiple containers? Do we need to create manually? No, we should automate that process. We will automate that. Kubernetes will take care of it. We have to just configure, we have to deploy some files. With those files, what will happen is that the Kubernetes will be able to successfully scale out the application, scale out the container, scale down the replica container. Scaling out means it will scale out the containers to any number based on our requirement, based on our CPU and memory utilization. Okay. So Kubernetes will be having master and worker concept. Master will be responsible for commanding the workers to do the work. The real containers will be running on the workers. Control plane is responsible for scheduling, assigning the load to the workers. We will see this very clearly. Understanding Kubernetes architecture is very important and very simple, provided that you learn it. Okay, each and every component, what is their work, how one component will interact with the other component, I will tell you clearly. Okay, so there are 2 ways to interact with the Kubernetes cluster. One is through user interface, which is not used, and one is through kubectl, which is very much used in 99% of the time. In real time, only kubectl will be used, but we will also see user interface also. Okay, kubectl is the client or the command line through which we will interact with our Kubernetes cluster, right? So we will understand various Kubernetes components. See, in Kubernetes, we have cluster. Cluster will be having nodes. Inside the nodes, we will be having pods. Inside the pods, we will be having our containers. So these containers will be managed by the Kubernetes with various higher level objects like deployments, replica sets, replication controllers, daemon set, and stateful set. We will see all those things. Okay.
Excuse
so there
me.
are 2. Yes.
Cluster means it's again a virtual machine.
Cluster means it's a Linux machines. They can be virtual machines or they can EC2 instances, right? Virtual machines. And EC2 instances are nothing but the virtual machines, right? So cluster means a master will be there. Master will also be a Linux machine, and workers will also be a Linux machine. Okay. So for example,
Okay.
yeah. So we have created a Kubernetes cluster. This will be acting as the control plane. Cluster means this is the control plane. This is the master. So we have to add the worker nodes. Worker nodes are nothing but again EC2 instance. Don't worry, guys. I will tell you all this in the classes. Demo cluster node. I want to demo node group.
Yeah, it's okay, sir. That's the doubt.
Yes. Okay. No. I have to create this, right? I'm waiting for the Kubernetes cluster to be ready. So I want to use which kind of EC2 instance? Let's use T3.small. So I want to have two nodes. Auto scaling also will be there for Kubernetes. Very beautiful tool, guys. This is. And in DevOps, if you learn Docker and Kubernetes, more weightage will be given to this Docker and Kubernetes only. In DevOps, Jenkins and other tools will also be there. If you attend for interviews, if you tell that you have the knowledge of Kubernetes and you work with Kubernetes, definitely they will be asking questions from Kubernetes, and there is more probability for you to be recruited. Believe me, there are less Kubernetes engineers uh, in this DevOps. Okay, people fear to learn it, but it is very beautiful, very simple to learn also. Okay, now I am adding two nodes. What are those nodes? Nodes are nothing but EC2 machines. Who will manage the node? We ourselves will manage the nodes. I will tell you that in the classes. Master will be maintained by the AWS itself. Okay, we don't know in which machine, machine it will be. Definitely it will be Linux machine, but we don't have accessible to do that control plane. It is our Docker host for Docker, and these two are the worker nodes. Okay, and these two are the worker nodes. As I said, in Kubernetes, we will be having master and the worker nodes. If we use the Elastic Kubernetes service, control plane will be managed by the AWS. Worker nodes are managed by us. We have the visibility into the worker nodes, but we don't have the visibility into this control plane. The downtime, without downtime, the AWS will be maintaining that service level agreement will be there, right? So it is the responsibility of the AWS to ensure that control plane is up and running always. And it is our responsibility to maintain this worker nodes. Okay. So now let me connect to this Kubernetes cluster. How to do that? For that, let me configure AWS first. For that, I have to install AWS CLI, right? As of now, that machine where I have installed all those things, I have deleted that yesterday. Forgot to have this demo. So anyway, so if you see our Kubernetes cluster, if you go to Elastic Kubernetes service, we have one cluster, and this cluster can be for dev. We can have another cluster for QA environment. We can have another cluster for prod environment. Okay. And this cluster, if you go inside this is a cluster or control plane which will be managed by the, it's a cluster means group of nodes. So if you go to compute section, we have two worker nodes. Okay. So these are the two worker nodes. And each worker node will be having these components will be installed by our EKS. When we join these nodes into this, the EKS service will install all these components in the worker node. So we just have to configure AWS credentials with our local machines, and we should have installed kubectl command line so that we will be able to communicate with this Kubernetes cluster. Okay, and we can deploy the things in Kubernetes cluster. Okay, so as a part of this, we have imperative approach, declarative approach. In imperative approach, we will be achieving the things with the command, but in declarative approach, we will be having Kubernetes manifest files. We will save all this manifest file in source code management tools. Okay, and from there we can pull this and we can deploy them into our Kubernetes cluster, guys. So we have resource code of our namespaces. We have services. Services means how to expose the Kubernetes deployments to the outer world using AWS load balancer. We will be able to do that. We will see that practically. You don't need to have the knowledge of AWS cloud. I will tell you the relevant services which we will be using in this course. Okay, service, cluster IP, all those things we will be learning. Ingress also very important. After ingress, we will also see an example for ingress. I will attach this load balancer with my own custom domain name. So I have my own DNS. So to that DNS we will see and we will understand how we will be doing in the real time. Scheduling means on which nodes we want to deploy our containers. We'll see times and tolerations concept, also see node selectors, node affinity, okay, resources for containers, how to create EKS cluster with screenshot. I have put up this into our documentation, how to connect to our Kubernetes cluster through kubectl command, how to install kubectl command, also very well explained here in this. Every step, you don't need to Google it directly, you can use all these steps, static pods and all those things, many more, okay. And so these are deployment file secrets, how we will be secret, you will be using the secrets. For example, how to connect to our own private registries called Azure Container Registry and Elastic Container Registry. So all these things we will be seeing, okay. So if you have any doubts, you can ask me, guys. Again, I want to reiterate the things. Actually, I planned this demo from 10 to 12, but I have some urgent work. So, and one thing is that I forgot to boot up this cluster earlier, so it will take some time, but I've shown you, but we did not go deep into that. That's fine. Because even if I tell you, you may not be understanding that because we have to learn Docker. So I want to just explain course. Course name is Docker and Kubernetes. Duration is 45 days. Okay. Somebody please go on mute, guys. Classes from Monday to Saturday. Okay. Class duration will be 1 hour. Okay. Fee is 4,000 and live plus recording also will be provided. Recordings will be provided along with the live classes. So if you miss some class, you can watch that recording. By end of every class, a recording will be provided by the end of that day. Okay, so course is very, very affordable, guys. I think these things will be followed up with the followed by the admin. So please subscribe to this, and classes will be starting from tomorrow. Timings will be 7 a.m. to 8 a.m. Indian Standard Time, IST. Okay, this is still. If you have any doubts, guys, you can ask me. And some people may be wondering why Docker and Kubernetes will take 45 days. It will be done in one or 2 weeks. I don't know how it can be done in 1 or 2 weeks. Okay, it will take definitely for 40 to 45 days. Okay.
And sir, one doubt, sir. So
yes.
Suppose, sir, I will go through the video and later I got some doubts, sir. So how I will ask you?
In the next class, you can ask me, right? Or else we will be having Telegram Telegram group. In that, you can ping your doubt.
Okay.
We'll interact with you there also. Okay.
Okay. And one thing, I want to go through like Linux and Ubuntu. So who can teach, or from where I will get this?
Linux or Ubuntu, both are Linux. Ubuntu is the Linux distribution, right? It's one form of Ubuntu. So Linux is nothing but the Ubuntu. Ubuntu is nothing but the Linux. As a part of Linux, Ubuntu is one version of that Linux. You can think of like that. Whereas distributions are there for Linux. Okay. So in that, Ubuntu is one thing. And you don't need to worry about the Linux as of now. Linux is not the prerequisite for this. Without Linux also, you will be able to do this. 1 or 2 commands we will be using, and those 2 commands I will be telling you. Okay. We will be using Docker and Kubernetes commands here.
And sir, for developer, like for back, like in company, sir, for a backend developer who is backend developer, so who will work for this DevOps environment? They are separate, with the developer only will do this one, or backend? Like...
Yeah, very, very important question. That is, nowadays, developer has to write the Docker file. Okay, so that means developer must learn the Docker.
Okay.
Because DevOps engineer will collaborate with the developers to deploy the application into the Kubernetes, and they will be building the pipeline. But Dockerization of the application needs development knowledge. So the DevOps engineer don't have the DevOps development knowledge, because we have to write the Python application has to be Dockerized, Java application has to be Dockerized, and some Spring Boot application has to be Dockerized, Node.js. So this DevOps engineer don't know all these technologies. Okay. So, but he has to collaborate with the developers. So developers should write the Docker file. 99% of the case, it is the responsibility of the developers to write the Docker file. Why? Because I will show you a Docker file for you. This is a Node.js application. Okay. So what is the working directory? DevOps engineers don't know. Developer has to tell this. Which files has to be copied to this working directory? Who will do that? The developers will know that. And which command has to be used? Okay. For Node.js npm install. As a DevOps engineer don't know this, doesn't know this. Developer has to tell this. And which port has to be, the application will be running on which port? Who knows this? Developer has to know this. Okay. So the final command. Okay, this thing, who knows this? Developer. So it is finally the role of the developer is very much there in this Dockerization of the application. So developers will be writing the Docker file. They will be pushing the Docker files to the repos. Okay.
So here the coding part is not there, no?
Coding part is there. Where go this copy package start.json is there, right?
Sub commands.
The coding will be yes. This will be this coding will be coming from the developers only. Okay. Or else, if you take a Spring Boot web application, see, this is the base image. Base image, we will understand that later. So work there. So this is the code is there, right? The jar file is there, right?
Yeah.
This is an artifact. Who will do this? Developers will do this, yes, right?
Yeah.
And it will be pushed into the Nexus or JFrog. So where this jar file has to be located, where this has to be copied into the environment, that has to be known by the only developer. Okay. So this command also.
And sir, when this batch started, sir? Sir, if I will join, so
tomorrow it will be started for 3 or 4 classes. So for 3 classes, everybody can join. After 2 or 3 classes, you will take a decision to join or not. So based on that, if you pay fee, then you will be allowed for the remaining classes.
Means from tomorrow starting will be there, or in between I will be there?
Tomorrow will be starting, and you can come at any point of time after paying fees, and live recordings will be available for you.
Thank you. Thank you.
Okay. Others, if you have any doubts, guys, you can ask me. Otherwise, we can wind up our session. So as of now, our Kubernetes cluster is ready. Yes.
So can I get the link or this course content?
Yeah, I will share that. I think they have prepared in their DURGASOFT portal. I will be searching that. So by Mr.Naveen faculty, the same content. My name is Laxman, but this is the content I will be using. This content, same content for Docker and available. So we will also see more concepts also. But as of now, you can take this as a reference. Okay, for reference. This is the content I will also be covering. I will see if there is anything missing. So we will see Docker containers, Docker volumes, Docker composition, Docker Swarm also I will cover, guys. In this course content, Docker Swarm is not there, but I will also cover Docker Swarm, which won't be used in the real time, but I will also introduce you to the concept of Docker Swarm also. Kubernetes, yes. Close config map secrets, network, storage, access control. The managed service also we will cover EKS and AKS. I think it is not covered here in this course content. Actually, I have my own course content, but it is there in my Windows machine. But unfortunately, I could not copy that. Anyway, so I will cover more things as well, but is also wide content only. Okay. But a few more things also we will cover. EKS and AKS clusters also we will see. We'll also see Azure Container Registry, how to connect with them and all. Right? Yeah.
Demo session completed.
Demo session in the sense for first demo sessions will be from Monday to.
I'm asking about today's class completed, sir. Only question and answers.
Yes, it is completed, guys. It is completed.
Once again, can you open your Kubernetes document, please?
Yes, I will open this for you.
Go to the top image, sir. First image gallery. Container గురించి చెప్తున్నారు కదా సరే ఇక్కడ ఈ లెఫ్ట్ పార్ట్ ఉంది కదా టూ ఇమేజ్ UI CLI and control panel.
Yes.
This is entire nothing but serverless.
Yes, we can think of so. Yes, AWS is managing them.
That's
we don't need to worry about what?
Serverless, and they can provide servers. You can't worry about these installments. I mean installations. Sorry.
Yes.
Okay.
AWS will be managing this. These two we have to install. This kubectl we have to install in our local machine. Okay.
That's
okay, guys. Thank you. If
Sir,
you have any doubts, you can ask.
Last one. So is there any kind of minimum configuration or anything as such if you're joining sessions on this machine?
You mean to say, is there any prerequisite course for this?
Yeah, prerequisite for the machine setup to be like this much RAM or that kind of stuff.
You should have AWS account, right? A free trial account is sufficient. Okay. If you use some paid service also, just it won't be that much. For example, if you are using EKS service, you have to pay for it. But daily you will be using 1 or 2 hours, right? For that, it won't be costing much. Okay. It's only manageable limit also.
Sir, మన system laptop లో చేసుకోవచ్చు కదా మొత్తం maximum.
Yes, you can do that. But what I'm telling is, in real time, you will be using the AWS cloud, right? So if I teach in the AWS cloud, that will be more like real time.
Okay, that's okay. You can teach.
Yes. So Kubernetes Minikube will be there. And there is also a problem. If you take Minikube, it won't be providing you the load balancer IP. But if you use the AWS will be providing load balancer, right?
Okay.
Yes.
So the concepts remain the same if we use Azure.
Yes. Concept remains the same. And one more thing is that whether you are using EKS or AKS, whatever the thing, the same concept, whether you are using Azure or AWS, same thing will be there. But where are we installing your Kubernetes? That differs. In AWS, we will be using EKS service. In Azure, we will be using AKS service. Every command, everything will be same. Okay.
So that EC2 and all that stuff, the OWS. So I'm not completely aware of that all. So
okay. I will teach you how to create the EC2 instance. I will teach you because we have to install our Docker in EC2 instance, right? So I will teach you how to create EC2 machine, how to connect to it. I will tell you. Okay.
Sir, then I have Azure account, sir.
Yes, you can have. That is also fine.
Okay.
In Azure, you have to create virtual machine. Here we will call EC2 machine.
Okay. Thanks.
Okay. Thank you, guys. I recommend all of you to have AWS account. Okay, very simple to create AWS account. All you need to have is credit card or debit card with international transactions enabled. Okay.
Sir, one more query, sir. Well, this course will help us to take any certification, sir?
Yes, with this Kubernetes, you can do certified Kubernetes administrator certification. You can pass it very easily if you practice this.
Okay, sir. Thank you.
Okay, tomorrow at what time, sir? 7 a.m.
No, could you please repeat your question?
Tomorrow at what time, sir? Class 7 o'clock, 7 a.m. Tomorrow morning.
Yeah, 7 a.m. to 8 a.m. Tomorrow
Oh.
morning is also.
So the link remains same for this tomorrow's class.
I don't know. Admin will tell you. Okay, they will be calling you or they will be mailing you. Please check your mail. Okay. So
Okay,
I'm also
thanks.
not sure. Okay. Thank you, guys. Thank you very much.
Thank you, sir.
Please.